We are on 11.5 of products. Nope, we are not on products and quotients. Yes, we are. Products and quotients of radicals. And this is on page 470 to 474. 470 to 474. So what we're doing today is we are simplifying radicals. We're learning how to simplify square roots, and we're going to multiply with some and get some answers. So there's a couple ways that there's just something I want you to think about. I know when we talked about the square root of 4, it equals 2. So because the reason why it equals 2 is because this also means the square root of 4 is the same thing as the square root of 2 times 2, correct? It's the exact same number times the exact same number. So I want you to think about, like, when you are playing Go Fish. Actually, hold on right there. I'm going to get a deck of cards. Okay. So you have a deck of cards, right? You got a deck of cards here. And remember playing the game Go Fish. So you had, 7 cards in your hand. 1, 2, 3, 4, 5, 6, 7. So to lay your matches down, you had to have 2 of a kind. 1, 2, 3, 4, 5, 6, 7. Okay, so here is my hand right here. Let me try to do this so that you can see them. So, and when I play, I always like to put my numbers in number order. I know, crazy like that. So let me do that. 3, 4, 5, 8, 10, and an ace. Okay, hopefully I'm not making you dizzy by watching this. Now, to get my matches, to get a point, is you have to have 2 of a kind. So if you look right here, I have a set of 4s. So I have 2 of a kind. Right there, 2 of a kind, okay? That means I get to set this down, and that's 1 point. It's kind of like what is up here. Say I had the square root of 16, which means 4 times 4. Oh, looky here. 4 and 4. Make sure you can see both of that there are 4s. I'm trying to do this right. There we go. 2 4s. Then that means it's 1 point of a 4, right? What I did here. So I need you to think of the game Go Fish. If you haven't played that game, I'm sorry. Maybe you can look that up and have your parents play it with you or your siblings play it with you during this time because it is fun. So, or Old Maid. Old Maid was the same kind of concept. Where you're looking for those pairs. So that's what I want us to think about today, is finding those pairs and knowing those perfect square roots. This is where knowing your multiplication comes in. Super-de-duper important. So first thing we're going to do is get that calculator out because we're going to work on those. So number 1, we're going to be working with that. It's the square root of 4,900. Well, the square root of 4,900 is 70. Let's do number 5. So it's the square root of 19,600, which if you look, the square root, we know the square root of 49 is 7, right? And that's times 100, which is 10, so that makes it to a 70. So that kind of makes that sense. I know 196, remember that's one of the ones I taught you, is the square root of 196 is 14. So if you punch into your calculator, you're going to see that the square root of 19,600 is 140. Well, let's go on to some that are a little bit more challenging. And we've learned so far where you would punch into your calculator the square root of 75. If you look at this, it is the square root of 75 is 8.66. 8.66. Well, you're not going to do that anymore. And you're not going to do that from here on out unless it tells you to round to the nearest point. What we're going to do is we're going to simplify it in radical form. In radical form. And this is really important. Okay, and the easiest way, the book shows you a way, and I'm also going to show you another way. And I like my way a little bit better. It's how it's how the Algebra 1 students are doing it, because the chapter that they're in there, it deals with this a lot, and it goes way quicker to figure these out instead of factoring. So I could take 75 and I could factor it down to 3 times 25 and then 5 times 5. But do you really want to make factor trees out for all of these? I know that those are probably not your favorite thing to do. They're not my favorite thing to do. I mean, sometimes we have to do it. We had to learn how to do it. But if you go about it the way that I'm going to teach you, it goes a lot faster. So I think to myself, what times what equals 75? And on one of those numbers, is it a perfect square root? Well, I kind of just put it on there for you. 25 times 3 equals 75. So, and 25 is a perfect square root. You can punch it in your calculator. You can see for yourself. So 25, the square root of 25 is 5, right? This is 5. And that's because 5 times 5 is 25. So I get to pull that out to the outside of the square root sign because I found a perfect square root for it. Well, what's left over? That got pulled out and got moved out here, the answer to that. So what's left over is this 3 on the inside. So I'm going to scoot it over so you can see it better. So that means this equals 5. This 3 got left on the inside, square root 3. There's our answer. Let's do some more. Number 9, and it is the square root of 216. Now, I'm going to go through and I'm going to see if my perfect square roots can go into this, okay? So I like to start high because this one's a big number. So I'm going to first see, I know 100 can't go into it. Can 81, because 81 is, the square root of 81 is 9. So let's do 316 divided by 81, and that equals, that's a big old decimal. That's not it. And then, so 64, let's see if 64, because that's 8 squared, which is 64, and the square root of 64 is 8. So can 216 be divided by 64 evenly? Nope, 3.375. We can't have any answers with a decimal. Well, I know 49 can't go into 216, so let's try 36, because 6 times 6 is 36. It's a perfect square. So we're looking here. We're going to go ahead and write to see what can go in here. So 216 divided by 36, and I get 6. So 36 times 6 equals 216. This is a perfect square. So the square root of 36 is 6. That gets to be pulled out because that is like our 2 of a kind that we found in our deck of cards. So this becomes 6 on the outside. That gets to go to the outside. It's done. And what's left is on the inside. Well, there's nothing else that can go into 6 that's a perfect square. So this is our simplified radical answer. Number 11. Number 11. The square root of 294. Okay, so let's try 64, because it ends in a 4. So let's see if 64 can go in it. 294 divided by 64. No. Let's see if 16 can go into it. 294 divided by 16. No. 294 divided by, we did 64. Let's do 7 times 7, which is 49. Divide by 49. And it's 6. It's a perfect answer here. So that is 49 times 6. Well, the square root of 49, mark that off, it gets to go to the outside, and what's left on the inside is the 6. It stays in there. Number 13, we're going to multiply now. So the square root of 2 times the square root of 3. And they don't even put this. Nothing. Now, these can't be simplified. That's like as simple as they can go. So when I multiply those together, I get the square root of 6. Can the square root of 6 simplify anymore? No. So that's your answer. Number 15. I get the square root of 6 times the square root of 3. Well, I get to multiply those two together. You just get to multiply, and I get the square root of 18. Well, can the square root of 18 break down? Well, I need to think. What goes into 18? Not 6 and 3, because see, neither one of these are perfect squares. But I do know that 9 times 2 equals 18, and this is a perfect square. So the square root of 9 is 3, and that gets to be eliminated, and what's left is on the inside is 2. And that got chopped off just a little bit. All right, let's go on. Number 17. This is the square root of 29 times the square root of 58. Now, these are both really big numbers. So I'm going to go ahead, I'm still going to go ahead and multiply them. 29 times 58 is the square root of 1,682. Well, I'm going to try to see if I can get a big square root to go into it. So 1,682 divided by, let's try 16. It doesn't work. I'm trying here. 1,682, but I keep punching the wrong numbers. So 1682 divided by 4. That doesn't work. So that process that I was doing, it doesn't work. So let's break down 58. This is the other way that the book can show you how to do it as well. So this is the square root of 29. And I can, since I get to smush this all under together, I can say times 58. Okay? This is equal to this, which is equal to this. Now, let's break down 58. I know 2 can go into 58, so 58 divided by 2 is 29. So this can equal the square root of 29 times 29 times 2. That's all under the square root sign. And look, I've got my 2 of a kind here. This is my pair that I get to pull out like in Go Fish. So it equals 29 on the outside, square root 2. Let's try number, let's skip to 25. And then we'll get into some division. So 25 is 5 times the square root of 6 times 2 square root 14. So this is on the outside of the square root sign on both of these, the 5 and the 2. So I get to multiply those two. So 2 times 5 is 10 square root, and 6 times 14 is 84. So now I got to think what can go into 84. Let's see if 16 can go into 84. 84 divided by 16. No, it can't. Let's see if, let's think of our perfect squares. So 6, let's see if 36, 84 divided by 36. No, it can't. Let's just try 4. 84 divided by 4 is 21. And 21 isn't a perfect square, so we can use that one. So this means 10 times the square root of 4 times 21. 21 breaks down to only 3 and 7. There's no 2 of a kind out of it. So, but there is with this 4. So, the square root of 4 is 2. So, I get to mark that out. Well, it gets to go to the outside. When it goes to the outside, that means it's going to get multiplied to this 10. So, then I get the 21 is left over. He has to stay on the inside. So, then 10 times 2 is 20. And then on the inside still is that square root of 21. So, that's the answer on that one. Okay, now let's get into dividing some of these. Let's go to number 27. Number 27, I'm sorry, I skipped way ahead. Number 23. Number 23 is the square root of 30 divided by the square root of 3. Now with the division, you kind of have to play with it a little bit to see what works best. So 30 isn't a perfect square, and 3 isn't a perfect square. But I can simplify this down. I can make it look like this and put it all underneath under a big one, like a fraction. Well, when I do that, it can simplify, because 30 divided by 3 is 10. So I can write the square root of 10 as my answer. Now, can 10 break down anymore? No, it's 5 times 2. There's no perfect square that goes into it, so that is our answer. 25. I get the square root of 9 divided by the square root of 81. Well, what's the square root of 9? This one I can see, they're perfect squares. Up here, the 30 and the 3 were not, but this 9 and 81 are. So the square root of 9 is 3, and the square root of 81 is 9. But this can reduce down to 1/3. 27. Oh, I think that's too far down there. Let's start this up at the top. Number 27. Number 27 is 5 times the square root of 10 divided by the square root of 2. Now, we can look at this and think, well, the square root of 10 can't break down. The square root of 2 can't break down. But I'm not even looking at the 5 yet, but 10 divided by 2 can break down. So let's write it like this. 5 times the square root of 10 over 2. Well, now 10 divided by 2 is 5. So that means this can equal 5 times the square root of 5. Number 29. The square root of 360 divided by the square root of 72. Well, 360, it looks deceiving because that 36 that we know is a perfect square root, but 360 is not a perfect square root. And 72 isn't either, but let's see what 360 divided by 72 is 5. So I could write it like this. 360 divided by 72 equals the square root of 5, because 360 divided by 72 is 5, but it still has to be under the radical sign to get our correct answer. 31. I have 2 times the square root of 80 divided by 8. Just 8. It's not under the square root sign. Well, when I see this right here, it's like a fraction. I can reduce that to 1/4. So now we technically have the square root of 80 divided by 4. Now, I got to break this 80 down to make it simpler. So I got to think, what perfect squares go into 80? Well, we could try. It's not going to be very high. Let's see if 36 can go into 80 evenly. 80 divided by 36, it can't. 80 divided by 25, it can't. We're getting closer because it was 3.2. 80 divided by 16, because 16 is a perfect square root, and it works. So we have 16 times 5 divided by 4. So the square root of 16 is 4, so that gets to come out on the outside. This 5 has to stay on the inside, divided by 4. These 4s, because it's being multiplied, are like a fraction there. It can cancel, so our answer is the square root of 5. We will, that's it for our lesson today. So if you have any questions, don't hesitate to reach out. And then we will start on 11.6 of sums and differences for our next lesson.